Okay, so let's talk about the mean of a discrete random variable. But first, let's have an experiment. Suppose our experiment is about tossing three coins at once. So we will be constructing a tree diagram to get our sample space. This is the beginning of our experiment. So when you toss a coin, the possible results are head and the tail. We will label this one as the first toss. Next, on our second toss, we will also get um, the outcome, which is tail, head, and a tail. On the third toss, it will also give us twigs that contains head and tail, of course. So we have tail, head, tail, head, tail, head, tail. This is our third toss. Now we already have our tree diagram. Next is to get the sample space. The sample space is the set of all the possible outcomes. So let's denote that one with a capital S. Now let's get the possible outcomes or the outcomes. We have head. So we'll be writing that one here. Head, tail. We have head, tail. Next, tail, head. Let's write it down. Head, tail, head, and head, tail, tail. Head, tail, oops, head, tail, tail. Okay, there we have it. And let's move on the other branch. We have tail, head. So let's write down tail, tail. Okay, tail. And we have tail, head. And lastly, we have tail. Okay, so this is our set of possible outcomes. Now, our random variable x in this experiment is the number of tails in every outcome. So let's count the number of tails in each outcome. Here, we don't have one tail or even a single tail. So that's zero tail. Here we have one, two, one, two, two, and three. Now this gives us the values of our random variables are 0, 1, 2, and 3. So after this one, we already have the sample space and the values of our random variable x. Now let's construct a table for our frequency and probabilities. All right. So let's complete first our table. This is 0, this is 1, this is 2, and this is 3. So we'll put space in here for the total. Okay. On the second column, we will be listing down our frequency or the number of occurrence. Now, the frequency of having no tail is 1 since it only occurred 1. The frequency of having one tail, let's see, we have 1, 2, and 3. So let's write down 3 here. The frequency of having two tails, that's 1, 2, 3. And the frequency of having three tails, we have 1 as well. Now let's get the total frequency. We have 1 plus 3 plus 3 plus 1, that's equal to 8. After we get the total frequency, we will now proceed to the probability in each outcome. So to get the probability in each outcome, we just have to divide the total frequency from each frequency. So we'll be needing a calculator for that. We have 1 divided by 8, that's 0.125. Okay, next we have 3 divided by 8. This gives us 0.375. The same here, since they do have the same frequency, 0.375, and here as well. 0.125 rather. So that's 0.125. Now we need to check if our calculation is correct. So that is by adding all the probabilities. We have 0.125 plus 0.125 plus 0.375 plus 0.375. Oh, I forgot. That's 37 rather. Let's do it again. 0.125 plus 0.375 plus 0.375 plus 0.125. Okay, so the total probability is 1, which is correct since the highest probability will always be 1 and the lowest is 0. Now, after getting the probabilities, we will then apply the formula for the mean. We will get the mean on each outcome. So the formula for the mean, which is denoted by the mu, is just equal to the summation of x times p of x. X here denotes the values of our random variable, and p of x denotes the corresponding probabilities. So let's write down here x times p of x. Now, the first column, the values in the first column will be multiplied to the values on the third column. So we have 0 times 0.125, that's 0. 1 times 0.375, that's 0.375. 2 times 0.375, let's use a calculator. 2 times 0.375, that's 0.75. And we have 3 times 0.125, that's 0.375. Now, after getting the mean in each outcome, we will then proceed to adding all the values in our mean. We have 0.375 plus 0.75 plus 0.375, that's 1.5. So this gives us the mean in this particular experiment is equal to 1.5. Now let us try to check that one by simply using the formula. We will directly use the formula. We'll calculate in here without using the table for us to compare whether they have the same results or they don't. Okay, so let me do that here. Okay, the formula for the mean, which is denoted by the symbol mu, let me erase this. It's just given by mu that's equal to the summation of x times p of x. So we have here the values of our x. We will rename this one as our x sub 1. This is x sub 2. This is x sub 3. And this is x sub 4. So to get this, we have x sub 1 times p of x sub 1 plus x sub 2 times p of x sub 2 plus x sub 3 times p of x sub 3. Um, we'll delete this one first. Okay, that's p. That's plus, not minus. X sub 3 plus we have x sub 4 plus p of x sub 4. Now we'll be substituting its values. Our x sub 1, that's 0, times our p of x sub 1, that's 0.125, plus our x sub 2, that's 1, times our p of x sub 2, that's 0.375, plus our x sub 3, that is 2, times p of x sub 3, that is 0.375, plus our x of 4, that's 3, times our p of x of 4, that's 0.125. So let's multiply. We have 0 times this digits, that's 0 of course, plus 1 times 0.375, that's 0.375, plus 2 times 0.375. So let's have 2 times 0.375, that's 0.75. And we have plus 3 times 0.125. 3 times 0.125, this will give us 0.375. Now let's add all these digits. We have 0 plus 0.375 plus 0.75 plus 0.375, that's equal to 1.5. So still they do have the same result, but if you want to construct a table for your data to be organized, you can also use the table or simply use directly the formula. You will still come up with the same answer. So that is how you will get the mean of a discrete random variable. If you do have questions, comment it down. I hope that you have learned. That would be all, and goodbye.